The other one is unsigned number. So when it is represented without any base format, it is nothing but an unsigned number. So when it is unsigned number, the default size is 32-bit. The default size it will take it as it is a 32-bit value, and the format also be a decimal. And other things are x and z values. X is nothing but unknown value. Z is nothing but my high impedance value. So unknown value is used to represent my output when you are simulating a program. So because only when I simulate the inputs, I will get to know what is my output. Until that, my output is unknown. Similarly, Z is my input. I will be representing my input variables as HIZ in my simulator. HIZ is nothing but high impedance state. So it is the transition between 0 and 1. So you will be having a clock pulse. So this is my Z. This is 0 and this is 1. So this is my Z. So at the beginning of the program or beginning of the simulation, I don't know the state of my input. It may be 0 or 1, but I don't know exactly. Well, based on the forcing, what I am going to force, I'll get to know whether it is 1 or 0. Meanwhile, till I force the value, my input will be in terms of Z, HIZ, high impedance state. If port mismatch or I have not called my subprogram properly, then my swapping of these variables will happen in the simulator window. So I can able to cross check whether the connectivity is proper or not. When you go for structural modeling or any other modeling, in the simulator window, if I have a value A as my input, and it should be shown as HIZ. Instead of HIZ, if it is shown as X, which means A is my input, but the simulator is considering this A as output. So there is a mismatch in the connection, or there is a mistake in the code. The vice versa also possible. Y is my output and it should be as X, but the simulator is showing it as HIZ. So its output variable, it should be yes, X, but the simulator considering it as a HIZ. That is my input value. So this is also wrong.
So while declaring the unknown value, we should always use X.
No need to use simulator itself, it will take.
Yes.
Only
Okay.
our aim is to write the module.
Hmm.
So I'll show you now how to write a code for AND gate and how to simulate it. We'll see.
Okay.
And this is for the base format for negative numbers. Yeah, it is an minus 6D3, a decimal value, which is of in 2's complement form. And two more symbols are there. One is underscore and another one is your question mark. So this underscore you can use in your module name. So as I already told, mux underscore 21 or 2x1, like that you can use. And this underscore is also used in the program for the readability of the data. As because we are using only zeros and ones, so continuous zeros and ones, a file of 1 MB with only zeros and ones, we may not know what is that exact data. To find the better readability, we can use this underscore between the data. At this size, we can define whether it is between 4 bit or next all the 4 bits are after 3 bits or after 5 bits. The based on our readability, we can use this underscore for reading purpose. And the question mark is alternative for Z. So here one more possibility is your UDP, user defined primitives. So as I already told, the truth table for an AND gate you have 0 0, 0 1, 1 0, 1 1. These four combinations are already available in the library function. By typing a keyword AND, I can able to get the output of this AND gate. I don't want this truth table. I want to have some more examples. I mean some more combinations at the input style. So instead of 4 combinations, I want to write 8 combinations or 6 combination of the inputs is also possible with the help of UDP. In that case, the EZ comes into picture. I can take one of the input as EZ and the other input as 0. And likewise, both the inputs are 0, EZ. Then what will be the output? Like this, I can write a code using this UDP. user defined primitives. So in that condition we'll be using this eject. So an example, 4-bit binary 10 question mark, so unknown values. Similarly, instead of this question mark you can use it as eject. Both are same meaning. So if you write anything between say double quote, then this will be treated as a string. And the normal identifier as well as keywords. Keywords are your library functions. Identifiers are nothing but our user defined.
Uh, can you go back, like on that said thing? Yes. So here in the example, we are trying to find the last two value, 4-bit 10ZZ. We are
Yes,
still trying to find the last two,
yes,
like
yes,
since it's
yes,
4-bit.
yes.
Okay.
Now let's write a program for an AND gate. Before that, I will go with the operators. So these are the different types of operators. We have a arithmetic operator, logical operator, relational operator, equality, bitwise, reduction, and more operators are there. So this arithmetic operator, multiplication and division, addition, subtraction, modulus, and here it is logical. This is logical negation, and operation. This is for or operation greater than, less than, or equal to. This is a equality. This is arithmetic case. This is a logic condition. This bitwise operation and the reduction operation more or less same, and shift operation, concatenation operation like this. This is my concatenation, and this is my replication, and this is my conditional operation. So in Verilog we have to use only the symbols to write the program. We should not use any words, so we'll be using only the symbols. So this is an AND gate program. The output of y is equal to a and b, or the Boolean expression will be a and b. So first I need to start with module followed by module name. So I'll say it is AND 21. Then I need to define my port list. So it is better to use the order. First you have to define all the out or call your all the output variables followed by your input variables. So here my output variable is y. I'll call my output variable y first. First my output variable followed by my input variables a and b. Next, I have to declare which are all my inputs and which are all my outputs. So again, I will go with my output first, output y, then input variables a, input b. So this is also possible, and you can write like this also, input a comma b. When they are of same size, you can use this statement or this one. Individual also you can define, or in a single line also you can define. So next is your which modeling you are going to use. First we will go with this data flow modeling. So data flow modeling is nothing but with respect to your Boolean expression. So Boolean expression is identified with the help of assign as a keyword. So it is my AND gate. So I'll be using a keyword assign for my output y is equal to a and b. As I told, you have to use only symbols in the program. Assign y is equal to a and b, then followed by end module. So this is a 2x1 AND gate program using data flow modeling. A simple one line code. That's all.
Yes.
So let's see how this code is simulated. So have you used this Xilinx simulator or model sim simulators?
No, I actually in college we used like Synopsys VCS tool, but
Okay,
I don't have idea about this one.
okay, fine. So it's nothing but your backend tool. You can do
Hmm.
both physical as well as logic simulation here. So I
Okay.
have integrated both model sim as well as Xilinx.
Okay.
So when I open this Xilinx, it will looks like this.
It's open source, I like free.
Yeah,
Uh,
yeah, open source. I will share.
okay.
So these are all my previous projects which I have done. Now let me close that and I'll open a new project. So you can first you have to browse your location. Can you able
Mm.
to see this window?
Yeah, I can.
First you have to browse your location, then give the project name. Let me give it as and 21. This will be the project name, not the module name. And I
Okay.
will take it as top level module as HDL. It may be schematic, EDF, and NGO. I'll take this as HDF and click next. These are the some of the FPGAs which we are going to dump our program and check the output. But
Hmm.
here we'll be using only the software part. So I'll take this Spartan 3E with a device family of 100E, package of
Hmm.
VQ100 and the speed grid as -4. The top level simulation is HDL and the synthesis tool is XST. Simulator is Model Sim. Generated simulating language is VHDL or Verilog. We will be using Verilog. Then click
Hmm.
next, next, next to finish. So now you can see here the sources in the project. Your project is created and 21.isc. Wherever you find a
Hmm.
file with the .isc
Hmm.
extension, which is nothing but a Verilog file, Verilog
Fine.
project.
Hmm.
Project.
Hmm.
So in this project, I have added my Spartan 3 device, so
Hmm.
which is shown here, the blue color highlighted one. I used to
Hmm.
tell this is a project or the device.
Hmm.
And see here, the process for source, nothing is here. One is design utility is there, create new source, add existing source. Only this terminal is here now. So
Hmm.
now I have to write a code using the simulator. So first right click on this new source. It will open this window. Here we have to select Verilog module, right? If you have VHDL, you can take VHDL. If it
Hmm.
is a test bench, you can test bench a Verilog test picture.
Hmm.
Similarly, VHDL test bench like that you can go for. So we are using Verilog module. Select this Verilog module and give the file name. This is the name of the module. Here you should not
Hmm.
start with number. So I'll take this as and underscore 21
Okay.
and you make sure this is added to the project. So if you want, you can declare your variables over here, whether it is A and the direction is input,
Input.
output or input like that. And what is the size of it? If it is a 1-bit value, no need to specify MSB, LSB. So if it is a
Hmm.
6-bit value, you have to define LSB as 0 and MSB as 6. Or the other way is also possible. For
Hmm.
all the variables, you have to use the same notation. Whether if MSB is 0 means LSB is maximum, you have to follow the same. Whether it is a big Indian or little Indian, you have to keep the common
Hmm.
formatting for all the variables when you define the size of the variable. So sometimes it will confuse us when you go for a complex design.
Hmm.
So
Hmm.
we leave here and this is our source type Verilog module, source name and 21 and the module name is and 21. So on the right hand side, you can see your editor window is open. This time scale 1 nanosecond for picosecond. The timing it required or then the waveform you can refer only with
Hmm.
respect to nanosecond or picosecond. So this is a
Okay.
time where it is created, what is the module name, and all these things will be shown here. And
Hmm.
this is the default syntax. Will be
Hmm.
comes like this: module, module name, followed
Hmm.
by this semicolon and end module. The
Hmm.
remaining things we need to type. So below the device, you can see the sources and port. My
Hmm.
Verilog file is being generated and underscore
Hmm.
21 dot
Hmm.
v. So dot
Hmm.
v means
That
it is
way is very
Verilog
low.
file
Hmm.
and dot vhd means it is a VHDL file. So now I need to define my variables. It is an AND gate 2 cross 1. So
Hmm.
first I told you how to take your output variable. So y first, then a and b. So you can use any variable,
Hmm.
but you should not use the same variable for both for input as well as output. So and output is y semicolon input a comma b. Now I have defined and declared my variables. It is a data flow modeling. I have to use the command
Hmm.
called assign. Y is equal to A and B.
Hmm.
So that's all about an AND gate program. Just click save. So you can see in the process view here
Hmm.
the compile
Hmm.
Verilog file and 21.v. So
Hmm.
here I have only one file, so it will compile only the particular file.
Hmm.
Suppose here in the previous project I had some 20 files. If
Hmm.
I click save, the recent file what I have worked will be
Hmm.
executing. So I may thinking that I need to run or compile an undegate file, but if I click save and run, it may run in a some other program. So you have to make sure that which program we are going to compile, that has to be selected, and then it should be. Now you can see the different tabs are added in the process. See, generate programming file, implement design, synthesis existing, user constraints, design utilities. All these tabs are added. So this is my process. So I expand this synthesis existing. I need to check the syntax of the program. So double click on this check syntax.
Hmm.
So it's running. So when it is a green color tick mark, the
Hmm.
program is succeeded without any syntax error.
Hmm.
Now, if you want to see what is the RTL schematic, the code, what it can double click on this view RTL schematic. A block
Oh.
diagram, your top
Hmm.
level symbol will look like this. Again, double click on it. This is the structure for which you have written a code. So
Oh.
out of this anywhere else, if you double click on it, again it will go back to the
Baba.
main module.
Hmm.
You can close this. Then double click on this view synthesis report. So in the synthesis report, you will get to know all of these things. The first one is your synthesis option summary, HDL
Hmm.
compilation, HDL analysis, HDL synthesis, and the synthesis report, level synthesis, and memory utilization and timing report. So
Hmm.
all the details you can study with the help of this view synthesis report. So mostly we'll be checking this final report. So top level module use and 21, and the number of IOs are 3. So 2 input and 1 output.
Hmm.
And cell usage, LUT we have used only 1. IO buffers we used 3. 2 is input buffer and 1 is my output buffer. So it is being shown here. And the device utilization summary. I am using this Spartan 3 kit. This
Hmm.
is having 960 slices, 960 ICs, out of which I am using only one. And then yeah, it is having a 4-bit LUT. The
LUT
number
is
of
a cell, right? Type of cell, is it?
and no, LUT is nothing but a truth table. So the predefined values will be already available there. It's
Okay.
like an image. You can cross check. Or instead of writing the program, you can directly call the LUT and you can minimize the length.
Okay.
So out of 1920, I'm using only one. The utilization is 0%. Again, it is 0%. And
Hmm.
IOBs, I have 66, out of which I'm using 3. So 4%. So out of in this Spartan 3, I'm using only 4% of the hardware. And how much time it takes to produce my output is this is the timing analysis. So within 9.4 nanoseconds, I am able to get the output of an AND gate by using my
Hmm.
Verilog code. So by forcing my in IOs, it takes 1.93, and the
Hmm.
net delay. This net delay is for my transmitting from input to output, the wire delay. So
Hmm.
this is for input buffer, and output buffer it takes only zero point 0.7, and this is zero point 0.08,
Hmm.
and output buffer it takes 4.87 nanoseconds. So overall if you calculate you will get a 9.45 nanoseconds. So out of which 7.5 nanosecond is for logic, that is the input transfer between the input or the time taken to transfer between
Hmm.
input to output or the
Output.
propagation delay, and
Hmm.
1.84 nanosecond is for routing for the wire delay, this one
Hmm.
is to delay of the wire. And if you add
Hmm.
this 3, it will be the buffer time or the input combinations whatever we are forcing. So that takes 7 point. So 80 percentage is for logic and this 19.6 percentage is for routing. So all these reports we can take using the synthesis report. And if you have any some other programming style like a behavioral modeling or structural modeling, so you
Hmm.
can cross check the synthesis report and you can write as analysis which one is providing better output with less number of devices and all you can check.
Okay. We can compare both of them.
Yeah, you can compare. Or you can compare the same Verilog program data flow modeling by
Hmm.
changing the device. So here I have used Spartan 3. You
Hmm.
can take some other device also. So in
Okay.
other in Vertex some other device,
Hmm.
write the same code and download it and check how much percentage it utilizes and what is the device utilization, what is the time required to complete the output and all you can analyze.
Hmm.
So next my syntax is over. Now I need to simulate it. So I can use this user constraints. This is for downloading my this program a bit file into an FPGA, that is nothing by Spartan 3. When you connect it through via JTAG cable, you
Hmm.
can download it. That is for physical design. Now we are going only for the logical design. So
Hmm.
we use this design utility. As I already integrated my model sim with this Xilinx simulator,
Hmm.
so double click on this launch model sim simulator.